So the seminar will be passed in three parts: ecological monitoring of the soil in general, implementation of phytoremediation, especially phytostabilization practices, and third part will be short information about my institute and possibility to connect with my colleagues. As you know, this year is celebrated as Year of the Soil. Soil last decades is recognized as national capital. That's why the protection of soil of different impacts is very actual and important things. As you know, soil is affected by different degradation processes. In Bulgaria, main process is soil erosion. It's about 70% of the soil in risk of water and wind erosion. Also, we have problem with salinization of the soil, with acidification of soil, and one of the biggest problem in Bulgaria is heavy metal contamination of soil. So this is short information. Where is Bulgaria? Bulgaria is in some east part of Europe at borders with Romania, Serbia, Macedonia, Greece, and Turkey. The area is 111,000 square kilometers. I think that is a little bit bigger than Portugal, but the people is about 7.5 million people. The cultivated land in Bulgaria is about 3 million, 4 million hectares, but contaminated soil is about 36,000 hectares. It's less than 1% of the used for agricultural production land. Till 2003, in Bulgaria, investigation of contaminated soil was used by expert determination of different places and common practice to receive information of this soil is not used. Additionally, Bulgaria, you know, was too close to the Soviet Union. That's why in Bulgaria all procedures, all methods were according to Russian rules. In 2003, starting to accept to European Union, we received one important question: how to harmonize Bulgarian standards with European. And in this project, we have the next tasks: review of situation of different countries, expertise on degradation process in Bulgaria, information about point relevant to soil and land status, standards for soil sampling and analysis, and evaluation of environmental and anthropogenic impact on soil quality. Idea was to plan a monitoring scheme for ecological evaluation of the soil. As a result of this project, we prepare a network with 446 points. This basic information is covered all parts of Bulgaria, and grid of this network was 16 kilometers. The obligatory was to repeat each 5 years all analysis. Analysis must be by using of ISO standards. For heavy metals, important was that we determine only pseudo-total heavy metal content. As a result of this basic level, was different changes in Bulgarian legislation. You see different ordinance, law of the protection of soil protection, ordinance of content harmful substances, ordinance for ecological soil monitoring, etc. One of the most important things in soil monitoring is to receive adequate soil information. Our Institute of Soil Science gives this information, and we recognize that pedological characteristics is mandatory for the basic level and detailed level of monitoring, and should be a general characterization, including a detailed description with information on soil parent material, and at least one profile description according to FAO guidelines. The soils then should be classified according to World Reference Basis, FAO 2006. The described soil profile should be selected as a location with this representative for the soil of the area. In 2013, under project with Ministry of Environment and Water in Bulgaria, was specified point information from the monitoring network by a number of taxonomic, chemical, physicochemical, and physical investigations were identified points. You see the information. The base that includes soil description, coordinates, land use, parent material, soil texture, profile description, soil type, horizon depth, sampling depth, the earth texture, chemical data, component of macro-micro elements, including heavy metals, harmonization of methods of analysis, detection limits. Now, for each of these soil samples, points of the monitoring, we have information with picture material, information of hard material, sheets, and profile description. Unfortunately, this type of investigation does not cover all our requirements. For example, for contaminated soil, it's not work well. Development and operation of the network monitoring does not provide enough representative information about the chemical degradation of soil. Following results from two complete expeditions, 2005-2010, confirmed the gaps of the soil contamination area. I will show you the first information we received in monitoring 2005. This is topsoil. You see the places with heavy metal contamination. This is the under topsoil. It's 20-40 centimeters. The next strip show much more contaminated places, and subtop layer we see some different. But this is not the all. Our institute in 2009-2095 prepared a scheme for contaminated area in Bulgaria. You see that the places with problem in soil contamination are quite more. And that's why we prepare a so-called second or detailed level of monitoring of soil. This base of monitoring is oriented to cover places with diffuse and local degradation. The grid of network here is 1 to 1 kilometer, and in some cases decrease till 0.2, 0.2 kilometers. The information has to be updated every 2 or 3 years. Some of points must be detected every year. Now indicators are a little bit different. Despite quite total concentration by aqua regia, we use additionally also bioavailability of heavy metals, soil biota, grass test, and we use all this information for risk assessment of for soil, for environment, and human. And now I would like to show you 2 objects in Bulgaria with problems in heavy metal contamination. First of them is Kremikovci, is steel plant near Sofia. It was closed in 2010, and the problem here is not only contamination of soil with lead and zinc, cadmium, but it's in the area of capital of Bulgaria, of Sofia. Many people producing here different vegetables go to market and sell them. That's why it's important to know which kind of production will be food safety here. Information about this plant show that here we really has ore with lead in this part of the, in this part of the Balkan mountain. We have also uranium mines, and the problem is too complex. In project 2003 with ETH Zurich, and after then in 2010 with Sofia municipality, we prepare a detailed monitoring map, and information was consisted of soil differences. We have here mainly cinnamonic soil, alluvial, diluvial soil. And this map shows us, give us reason to prepare interpolated maps for the risk of contamination of different elements. First of them is changes in pH, because in Bulgaria the toxicity of heavy metals is quite related with soil pH. We see the low pH, the high pH. Concentration of cadmium, copper, lead. All this area could be used for recommendation of different type of land use, and we recommend to the people, to the farmers, to the cooperatives working there, to select the right crop for each pollution level. Intensive monitoring must be carried out for soil and crop quality. Highest pollution level, the places must be used for production of flowers, seed production, and with lower pollution level, traditional agriculture, potatoes, selected vegetables without leaf vegetables because of the dust contamination. The second object is located in south part of Bulgaria. It's the town of Plovdiv, where still work non-ferrous plant with high capacity of production. The problem here is that the soil climatic condition give a reason for the people to produce 2 or 3 different yield per year. So very actively used land. The problem here is also that close to the plant lie this Rhodopa mountain, a village of Kuklen with detected problem in soil quality and health of the people. In 2004-06, we prepared a map for monitoring of the soil. This is with grid 1 to 1 kilometer, combined with the Institute of Soil Science Bonn was prepared this map. The problem also here is that all material for exploitation in the plant is coming out in Rhodopa. That's why the way is very high contaminated. The problem here is also that concentration of the contaminants here are about 10,000 ppm for lead, about 6,000 for zinc, and 2010 for cadmium. It's surpassing more and more times permissible level content. Because here the contamination is multi-elemental, we prepare this bomb with hot points of the place. You see that near the smelter, near the chimney, concentration is very high, and after that they decrease. We could not remediate this plant. That's why use the technique for decision support and give the next approach to select the right crop for each pollution level, to do intensive monitoring of soil and crop quality. Highest pollution level is used for production of etheric oils, trees. In Vigo, I show a picture with lavender. Now is lavender. Before this, it was salvia. And lower pollution level must be used for production of vineyard, orchards, etc. Unfortunately, the people want to receive vegetables, and from time to time, we make discussion with the people that this is mainly for their hurt. So this is short information about monitoring, preparing in Bulgaria for contaminated soil, and decision support scheme for their use. The next one is implementation of phytoremediation. So phytoremediation, you know, has different derivatives. You use now the phytostabilization. The object I will show you is located in 70-kilometer distance of Sofia. Here is are located 4 big plants for mining industry, for extraction of copper and extraction of gold. A problem is also that the border of these plants are bordered with National Park Central Balkan. That's why information about soil status is very, very important. You see, what was our goal? To use regular perennial grass mixture near a functioning copper smelter at Pirdop. You use a combination of revegetation with addition of amendments to immobilize heavy metals and increase soil fertility. So phytoremediation is a too complex trial, and in this work we use knowledge of biologists, chemists, agronomists, local farmers, etc. We must survive this very high contamination with copper. It's 0.5%, strongly acid of soil, pH 4, and only marginal natural vegetation. You see on the picture, there is no practically any vegetation. The copper uptake is surpassed many times sanitary values. So here the problem is not only in functioning of the plants. We have, you know that where there are mining industry, the background of the heavy metals is higher, and practically here the toxicity of the copper is mainly due to low pH. Selecting of object, we found we planned 3 types of experimental trials. First of them is greenhouse experiment, second using of mesocosm, and the third is field experiment. For greenhouse experiment, we select 3 species, cabbage, alfalfa, and lettuce. Lettuce is well known as indicator for contamination. Cabbage is traditionally produced in this area. Alfalfa is for grazing and used of the farmers in the area also. The basic information about the soil show that only pH, not only pH is problem, pH 4, but the concentration of copper is very high. Concentration of zinc is 2, the concentration of lead is higher. You see, concentration of arsenic in Bulgarian legislation, it's about 25 is limit for toxicity of the arsenic. But in this area, the background values of arsenic are really very high. First experiment with cabbage give us reason to accept for future investigation carbonate deposit lime material at 2 doses, coal powder and peat. The first experiment showed that positive effect of the biomass and reduce of transfer of heavy metals in above ground portion were observed in the variants given classical lime material. Optimal doses of amendment are reported on variant with higher concentration of lime material. We assume that the optimal values of parameters stood in both versions due to reaching of the pH 6. Peat can be successfully used in combination with lime material, and the effectiveness of the peat increases in parallel with the lime rate. The combination of coal powder with lime material is less effective. After then, we started the next one experiment with lettuce in complex scheme, 50 variants. You used lime material, peat, zeolite, organic compound, coal powder. This information was based for a PhD thesis. The combination of variants is showed. It's 50 in 3 replications. The parameter we want to determine humus fraction, biomass, ash components and biomass, copper content, humus fraction, exchangeable cations, sorption pH, cation exchange capacity. And first experiment was quite similar to yours in your institute. First results are related to changes of soil pH. You see increasing of pH after incorporated of amendments and after growing. The highest value of pH we have with application of lime material. Variants with peat and ferric hydroxide support pH below 6. Dry weight of the lettuce is a very indicative parameter. We show that maximal biomass could receive from variant lime and ferric hydroxide. Depression we have after incorporation of lime only, or of peat only. Copper content is very important parameter. Decreasing of concentration in variant 2 and 3 is due to application of lime material. It's very important to say that zinc concentration, if you remember, it's not so high, but the concentration in material is very high. At limit 50, all variants surpassed sanitary value. Exchangeable copper and zinc, this is extraction with EDTA, showed that lower available concentration of copper and zinc due to amendments with application of lime material, and only application of peat lead to increase of heavy metals. Conclusion of this experiment is that as optimal can outline variants that provide increasing of soil pH and improve the physicochemical characteristics. There are organomineral combination of lime material and iron hydroxide, peat and iron hydroxide, peat and zeolite, and ferric hydroxide with ash. the best choice in terms of productivity and decreasing of heavy metals content are variants with lime material and ferric hydroxide. Organic and mineral mixture of peat with ferric hydroxide and lime and zeolite show a positive effect to top formation of plant biomass and immobilization of copper and zinc ions. The next experiment is so-called mesocosm experiment. Design of this pot is from Altera. This is a part of common investigation on Phytodec project. You see the opportunity to check transfer of heavy metals in different depth. Artificial roots we have in 15 and 45 and in the top. Leach sheet collector is informative for the transfer of heavy metals in underground water in the place. This is the picture of the mesocosm pots. Aim of this study was to investigate the effect of different amendments and combination of physical-chemical properties on soil and transfer of heavy metals in system soil plant water. Tasks are select the optimal variants, bioavailability of heavy metals, and to do risk assessment. Mesocosm experiment was combined of 24 variants with lime material, peat, ferric hydroxide, zeolite, coal powder, and agroperlite. The picture of the experimental. So, the highest level of copper and zinc pass and expire in depth. All the variants with medium level of lime material and coal powder. You see the differences in variants. Having in mind the different depth and artificial roots, we found also that variant with peat is higher than control variants. The same is for zinc. Mesocosm copper concentration in green parts. Grass tree showed that maximal concentration of surface biomass we have in variants with application of lime material, and lower concentration and higher concentration of copper we have with variants with lime material, so with peat material. So field experiment is carried out parallel with mesocosm experiment. On the field we prepare 15 different combination with peat, lime material, zeolite, agroperlite, ferric hydroxide, and farmer manure. You see the place for our experiment. This is the chimney of the copper plant. This is the remediated 20-30 years place, and this is the yard of school, high school in Zlatica. you see no vegetation, the soil is totally destroyed, and this is for practice, but no can survive here. This is the place before starting our trials for phytoremediation. We use seed mixture with wheat, alfalfa, amaranthus, festuca, etc., and tree. We see the survival and the planted species. Next slides, I will show you how this practice carried. See you later. And this is 1 year after starting the experiment. Now situation is similar. This is a small forest, and we try to use high energy plants, miscanthus, growing here. So now there is no problem, no new problem. This is like a joke. The teacher from this school said, okay, it is very good, but the schoolboy go there to smoke, and we can see them. So this is for the first time. I would like to say that many of the questions could be discussed later, and I'm still think that idea for soil monitoring and practice of phytoremediation is best for real discussion now. Unfortunately, I don't know what is the practice in Portugal concerning soil monitoring, and I know that Dr. Abreu will show me the practice of phytoremediation. That will be useful for both sides.
Thank you.
So.